look at shifting property. We compute integral of negative infinity to infinity x of t. This is delta of t dt. Delta of t represents impulse function, and here it says x of 0. When the time is 0, if you integrate impulse function with respect to t, you're going to get x of 0 times 1, because if you integrate impulse function, you should get 1. So x of 0 times 1, the x of 0. So the final answer you get is x of 0. In words, this equation says that the area under the product of x of t times delta of t is simply the value of x of t at time is equal to 0. The impulse function shifts out the value of the function x of t at the location of the impulse. Hence, it is called the shifting property of the impulse function. Very similarly, we compute integration negative infinity to infinity x of t, this delta of t minus t dt. So if you see a shift, like a time shift by t or anything, at that time, if you integrate the impulse function, you're going to get 1 again. So x of t, if you take this one out and integrate minus infinity to infinity, and then they combine this one into alpha, so delta of alpha d alpha is x of t times 1, that is x of t. Again, the impulse function has shifted out the value of the function x of t at the location of the impulse function. And here, impulse function properties summary, properties of delta of t. First you see x of t is x of t delta of t minus t naught is equivalent to x of t naught delta of t minus t naught. You have to just look at the shift, and that's going to be the x of whatever the time value is. And then here integration negative infinity to infinity x of t integration of t dt. So if you have negative infinity to infinity integration and x of t, this is basically like if you have t without any shift or anything, that's basically x of 0, like the time 0 integration. So you see the x of 0, and this whole thing will come, you move this one out, and this whole thing become 1, and you get x of 0. That's the one we looked at over here. This is the one that, okay. And then delta of t is equal to delta of minus t. That's why you see, like, even if you get negative shift or positive shift, you're still gonna get delta of t. You will see it later here as well. Integration negative infinity to infinity x of t delta of t minus t naught. So when you have a shift, you do the integration, like the time becomes that, like instead of 0, like if you don't have any shift, that's 0. If you have a shift, that shift becomes the time t naught. Time, in this case, this t naught because t minus t naught. And again, even if it's plus t naught or minus t naught, it's still x of t naught. And if you integrate the inverse function, that's 1, and you get x of t naught alone, x of t naught alone. And here negative infinity to infinity x of lambda, this delta of t minus lambda t lambda. Here we are getting x of t because we are integrating this one with respect to lambda. So the t is the time shift. So that's why we are getting x of t right here. And then integration t1 to t2 x of t delta of t minus t naught is dt. So here again the shift is x of t naught, and we get x of t naught if the time, if this t naught is between t1 and t2, because we are integrating with the beginning of the integration is t1 t2. So the beginning and the ending, if the t naught is in between these two, then only that is x of t naught, otherwise you're going to get 0. And if you find the derivative of unit step function, that is impulse function, and if you impulse and unit step function is equal to integration of an impulse function from negative infinity to t, and this is the one, and the final t will become the u of t, the time unit step function is going to have. And that's basically it. I hope you guys find this video helpful. Thanks for watching. Don't forget to subscribe my channel. See you guys on my next video.